Right now, a typhoon with 125 mile per hour winds and 52-foot waves is closing in on Japan's southern islands. It is still 500 miles out, and it is already generating waves taller than a 5-story building. 4 days ago, this same storm had winds of 45 miles per hour. Then, it did something almost no storm in recorded history has done. It tripled in power in 36 hours, hitting 165 miles per hour and reaching Category 5. Its winds jumped 95 miles per hour in a single day. That is nearly 3 times the speed increase that already qualifies as rapid intensification. And it set that record in a part of the Pacific where no storm has ever reached that strength before. This is not a typical Pacific typhoon following a familiar path. Something larger is driving this. Dolphin is the 5th Category 5 storm on Earth this year. That is a pace the planet has not seen since 1997. Today, we are going to break down exactly where this storm is heading right now, who is in its path, how it grew so fast, and what the Super El Nino behind all of this means for the months ahead. No guessing, no dramatizing, just the official tracking data, the science behind the records, and the real stakes for the people and places in this storm's way. If you have ever lived through a typhoon, or if you were stationed at a Pacific base during a major storm, tell us what that experience was like in the comments. We read them, and other viewers learned from them. And if this is the kind of reporting you count on, the story's mainstream news skips past, subscribe and hit the bell so you do not miss what comes next in this record-breaking storm season. As of August 3rd, Typhoon Dolphin is 824 kilometers east of Iwo To and closing in. Its sustained winds are still at 125 miles per hour. That is a Category 3 storm, weakened from its peak, but still capable of catastrophic damage. Wake Island is a tiny American atoll sitting alone in the open Pacific, about 2,300 miles west of Hawaii. There's no city there. There's no coastline nearby. There's only ocean in every direction for hundreds of miles. The Joint Typhoon Warning Center in Pearl Harbor picked up the disturbance and gave it the designation 12W. That is the 12th tropical cyclone the center has tracked in the Western Pacific this year. The Japan Meteorological Agency, which handles official naming in this basin, called it Typhoon number 13 and gave it the name Dolphin. The name was contributed to the World Meteorological Organization list by Hong Kong. It refers to the Chinese white dolphin, a small pink-colored dolphin that lives in the waters near the Pearl River Delta. For the first 2 days, Dolphin behaved like an ordinary tropical storm. Then something changed. The storm crossed into a stretch of ocean that forecasters do not usually watch closely for super typhoons. It reached Category 5 strength at 106.5 degrees east longitude. That number matters. It is the farthest east any storm has ever reached that intensity in the Northwest Pacific Basin. The previous record was Typhoon Faye in 1968, which hit Category 5 at 162.7 degrees east. Dolphin pushed the record almost 4 full degrees of longitude farther east. That is roughly 240 miles beyond the old boundary. To understand why that location matters, you have to understand the international date line. That is the imaginary line that runs through the middle of the Pacific, at 180 degrees longitude. Storms that form this far east in the Western Pacific are rare. Reaching Category 5, there had never been recorded until Dolphin did it. The reason is fuel. Storms need warm water to grow. The ocean surface beneath Dolphin was running between 84 and 86 degrees Fahrenheit. The normal temperature in that part of the Pacific at this time of year is about 82 degrees. 2 to 4 extra degrees may not sound like much when you're standing on a beach. In the atmosphere above a developing storm, it is the difference between a passing squall and a super typhoon. The other ingredient was the wind above the storm. Forecasters measure something called wind shear. That is the difference between wind speed at the surface and wind speed high in the atmosphere. When shear is strong, it tears developing storms apart before they can organize. Above Dolphin, shear was only 5 to 10 knots. That is almost nothing. The storm had warm water below, calm winds above, and no land in the way. It had everything it needed and nothing standing in its path. The result was a storm that grew in a location where the atmosphere is not supposed to support this kind of growth. This is what forecasters mean when they call Dolphin a record breaker. It is not just the wind speed, it is the geography. This storm reached the top of the scale in a part of the ocean where storms of this size are not supposed to exist, but the location was only half the story. What happened next in the hours that followed is what put this storm in the record books a second time. On Monday, July 28th, Dolphin was a tropical storm with modest winds around 45 miles per hour. By Wednesday morning, July 30th, it was a 165 mile per hour Category 5 super typhoon. That transformation took less than 36 hours. To put that in scale, most tropical storms take 5 to 7 days to reach Category 5 strength, if they get there at all. Dolphin did it in a day and a half. Forecasters use a specific term for this kind of growth. They call it rapid intensification. That is when a storm's winds increase by at least 35 miles per hour in a single 24-hour period. Dolphin's winds increased by 95 miles per hour in one day. That is nearly 3 times the official threshold. Fox Weather reported the 95 mile per hour jump. A separate 24-hour window measured by the Joint Typhoon Warning Center showed a 150 km per hour increase, which is roughly the same figure in metric units. This was the fastest intensifying storm in the Western Pacific since Typhoon Noru in 2022. And Noru is remembered as one of the most explosive storms in recent record. The peak came on Wednesday, July 30th. Sustained winds hit 165 miles per hour. That is a super typhoon. Super typhoon means sustained winds above 150 miles per hour. It is the strongest classification the U.S. military's tracking center uses. At the same time, the minimum central pressure inside the storm dropped to 910 millibars, according to the Yale Climate Connections analysis. The Japan Meteorological Agency, working through weather news, measured it slightly lower at 905 hectopascals. Either number puts Dolphin near the low end of what storms on this planet ever achieve. Lower pressure means a stronger storm. Dolphin was extremely low. Something else happened as the storm exploded upward. Its eye, the calm circle at the center of the rotation, shrank. Fox weather measurements during peak intensification showed the eye at just 6 to 7 miles wide. Forecasters call that a pinhole eye. That is when the inner ring of thunderstorms around the eye contracts to an extremely small radius. Pinhole eyes are the atmospheric signature of a storm operating at maximum efficiency. All of the storm's energy is packed into a tiny, spinning core. When you see one on satellite, you know the storm is at its peak. Around the pinhole eye is the eye wall. That is the ring of thunderstorms surrounding the eye, and it is where the strongest winds live. In a Category 5 storm, the eye wall is a wall of 165 mile per hour wind that stretches from the ocean surface to the top of the atmosphere. The Japan Meteorological Agency classified Dolphin as a violent typhoon. That is their highest designation. It requires sustained winds above 105 knots, which is about 120 miles per hour. Dolphin blew past that threshold and kept climbing. The National Weather Service office in Guam issued a discussion on July 29th. In that document, forecasters noted that Dolphin had added 75 miles per hour of wind speed since the previous day's discussion. That was one office, watching one storm, updating their own numbers 24 hours apart and finding a 75 mile per hour difference between the two. Try to picture what that looked like at sea. On Monday, ships in the area were tracking a storm with tropical storm force winds. By Wednesday morning, they were looking at the strongest storm on the planet in 36 hours. When the numbers were confirmed on July 30th, Dolphin was no longer just a powerful storm. It had joined a list that only 4 other storms in 2026 had reached. And that list is telling us something about what is happening on this planet right now. Dolphin is not an outlier. It is the 5th Category 5 storm on Earth in 2026, and the year is not even 2/3 over. The first was Cyclone Horatio in the South Indian Ocean on February 23rd. Horatio reached 160 mile per hour, sustained winds far from any populated coast. The second was Super Typhoon Sinlaku, which hit Category 5 strength near Guam on April 12th with 185 mile per hour winds. Sinlaku went on to strike Saipan as a Category 4 storm. It killed 17 people and caused damage estimated between $458 million and $1.5 billion, depending on the source. The third was Typhoon Bavi, which reached Category 5 over the western Pacific earlier in the summer and later disrupted shipping along the eastern coast of China. The fourth was Hurricane Genevieve, which spun up in the eastern Pacific just 72 hours before Dolphin did the same thing on the other side of the ocean. Then came Dolphin. 5 Category 5 storms in 7 months. The all-time global record for a full calendar year is 12. That record was set in 1997. Right now, 2026 is running ahead of 1997's pace, with 5 months still on the calendar. In 1997, the 5th Category 5 storm of the year was Typhoon Winnie. Winnie did not reach that strength until August 12th. Dolphin got there on July 30th. That is nearly 2 weeks earlier than the previous record-holding year. The 1997 season set another record too. The accumulated cyclone energy index for the Northwest Pacific that year was 594. ACE is a measure that combines the strength and duration of every tropical storm in a basin over a season. A 594 was, and still is, the highest ever recorded for the Northwest Pacific. Meteorologists have been watching for a year that could challenge that mark for almost 3 decades. 2026 is now on that watch list. What connects 1997 and 2026 is a climate pattern called El Nino. El Nino is a natural pattern where the central Pacific Ocean gets warmer than normal. When it does, weather patterns shift all over the world. The Pacific makes more powerful storms. The Atlantic makes fewer. Rainfall increases in some regions and drops in others. Fisheries collapse in parts of South America. Droughts intensify in parts of Asia. The strongest version of the pattern is called a Super El Nino. That is when the warming in the central Pacific crosses 2 degrees Celsius above the long-term average. Super El Nino has only happened 5 times since 1950. The last one ran from 2015 into 2016. The current warming, according to data collected by SOFAR Ocean, is already at 2.1 degrees Celsius. We are past the line. NOAA, working through analysis reported by Fox Weather, currently puts the probability of the El Nino reaching very strong or super status by the October to December window at 81%. That is close to a lock. And if it holds, more storms like Dolphin are on the way. We have a recent example of how bad this can get. In 2015, during the last Super El Nino, a different Typhoon Dolphin brushed past Guam with gusts over 106 miles per hour, and later peaked at 160 miles per hour over open water. Even without a direct hit at full strength, the storm knocked out 40% of the island's power and caused $13.5 million in damage. And that was in a year still ramping up into full Super El Nino conditions. This year, we are already past the threshold. The warmer Central Pacific is the fuel supply. It gives storms more energy to work with. It also lets them form and intensify farther east than they normally would. That is exactly what Dolphin did. Its record-setting longitude is not a coincidence. It is what a Super El Nino looks like from the perspective of a satellite watching typhoons. But records and patterns are numbers on a chart. What matters now is where the storm is going and who is sitting in its way. As of August 3rd, Typhoon Dolphin is 824 kilometers east of Iwo To and closing in. Its sustained winds are still at 125 miles per hour. That is a Category 3 storm, weakened from its peak, but still capable of catastrophic damage. Zoom Earth is tracking Dolphin's current position at 824 kilometers east of Iwo To. AccuWeather is measuring sustained winds at 125 miles per hour and gusts at 155 miles per hour. Zoom Earth is also reporting significant wave heights of 52 feet, or 15.8 meters, around the storm. Significant wave height is the average height of the tallest one-third of waves. When that number hits 52 feet, individual waves can be much larger. A 5-story building is about 50 feet tall. Waves that tall are running under Dolphin right now. The storm's field of destruction is enormous. Hurricane-force winds, meaning sustained winds above 74 miles per hour, extend 90 kilometers from the center. That is 56 miles. It creates a circle of destructive wind 112 miles across. Gale-force winds, above 39 miles per hour, extend 370 kilometers from the center on the northeast side. That is 230 miles. A storm that wide affects entire island chains even without a direct hit. The first islands in Dolphin's path are the Ogasawara Islands, also known as the Bonin Islands. They sit about 620 miles south of Tokyo. The main inhabited island is Chichijima, with a small year-round population. Iwo To, which most Americans still know by its wartime name Iwo Jima, is farther south in the same chain. Iwo To is home to a Japan Self-Defense Force air station. There is no civilian population on the island. The Joint Typhoon Warning Center's current forecast shows Dolphin passing very close to Iwo To on Tuesday. Farther west sits Okinawa. Okinawa has a population of 1.47 million. It hosts Kadena Air Base and multiple other U.S. military installations. If you have served in the Pacific in the last 60 years, there's a strong chance you spent time on Okinawa. The island's U.S. bases are already in seasonal tropical cyclone condition of readiness posture. TCCOR is the alert system U.S. forces use across the Pacific during typhoon season. The scale runs from TCCOR 4, which is a general season alert, down to TCCOR 1, which means damaging winds are hours away. According to Stars and Stripes, base leadership may upgrade TCCOR on Monday or Tuesday, depending on Dolphin's track. Even if the eye passes hundreds of miles east of Okinawa, the Ryukyu Islands, the long chain that stretches from Kyushu down to Taiwan could still see typhoon-force winds. The storm is that wide. Beyond the Ryukyus, the extended track brings Dolphin toward the East China Sea. 2 Chinese provinces sit downstream. Fujian province has a population of 42 million. Zhejiang province has a population of 65 million. That is 107 million people between 2 coastlines that could be affected by whatever Dolphin becomes over the next 7 to 10 days. The South China Sea will feel the storm too, even without a direct passage. Forecasters expect force 6 to 7 winds and 2 to 4 meter waves across the Paracel and Spratly zones by August 6th and 7. Force 6 and 7 on the Beaufort scale means winds of roughly 25 to 38 miles per hour. That is enough to complicate shipping across one of the busiest maritime corridors on the planet. Shipping is already under pressure. Eastern China's major ports are still working through congestion caused by Super Typhoon Baby earlier this summer. According to reporting from Khaleej Times and Hellenic Shipping News, Dolphin could compound the backlog if it forces additional port closures. There is one wildcard in the forecast. The HAFS-A model, one of the newer hurricane forecasting systems, is flagging a possible re-intensification as Dolphin approaches Okinawa around day 5. Re-intensification means the storm's winds could climb back up after having weakened. That is not the primary forecast. The consensus track shows continued gradual weakening, but it is a scenario forecasters are watching. Zoom Earth is monitoring the model output and updating the risk picture. One more piece of language worth explaining. Dolphin's track is being shaped by a feature called the subtropical ridge. That is a large, semi-permanent area of high pressure that sits over the Pacific during summer. Storms curve around the edges of the ridge like water flowing around a rock in a stream. Where the ridge sits determines where the storm goes. Right now, the ridge is holding Dolphin on a west-northwestward track. If the ridge shifts, so will the storm. The models mostly agree on the direction. What they do not agree on is how strong Dolphin will be when it gets there. Right now, ocean buoys in Dolphin's direct path are recording what the storm is doing to the water beneath it in real time. A SOFAR ocean spotter buoy floating 150 kilometers from the storm's center has recorded significant wave heights of 5.25 meters. That is a data point flowing back to forecasters every few minutes. 20 years ago, that number would not have existed. Today, it is part of the operational picture. The Joint Typhoon Warning Center is tracking 2 specific things closely. First, eye wall replacement cycles. That is, when the inner ring of strongest winds around the eye weakens, and a new ring forms around it. The storm pauses, then often comes back wider, sometimes stronger. Second, forward speed. Dolphin has been slowing down. A slower storm spends more time over any given patch of ocean, drawing up more heat, and delivering more rainfall to any land it eventually reaches. The Japan Meteorological Agency has issued marine warnings for the Ogasawara Islands. Zoom Earth notes Dolphin is on a gradual weakening trend, but the HAFS-A model still points to possible re-intensification within the week. Yale Climate Connections has called this storm historic and explosive. Their analysts describe Dolphin as entirely consistent with a very strong El Nino. Gizmodo, summarizing the season so far, has written that Earth is on track to break the all-time record for Category 5 hurricanes this year. And the peak months of the Pacific typhoon season, August, September, and October, have barely started. If 2026 continues to follow 1997's trajectory, with the Super El Nino strengthening into the fall, more Category 5 storms are likely before winter arrives. The buoys, the satellites, and the models are all pointing in the same direction. The storm will eventually weaken. They all do. But what it leaves behind, in the data, in the records, in the pattern it belongs to, that is what we should be paying attention to. Think about the contrast between 1997 and 2026. In 1997, the world did not have real-time ocean buoy networks. It did not have satellite-based artificial intelligence track models. It did not have globally coordinated warning systems talking to each other in near real time. The storms that year were just as powerful. The waves were just as tall. The pressure inside the strongest typhoons dropped just as low. But the communities in their path had less warning and less data. In 2026, we can watch a typhoon's eye form from space in the same minute it appears. We can measure its waves from a floating sensor 150 kilometers away. We can model its intensity 3, 5, and 7 days out with a level of confidence that would have seemed impossible a generation ago. The storms are not new. What is new is that we can see them coming, measure them, and choose whether to act on what the data says. The record here is not the storm itself. Dolphin is just the messenger. The record is how many signals like this the planet has to send before the pattern becomes impossible to ignore. 5 Category 5 storms in 7 months. A super typhoon in a stretch of ocean where one has never been recorded. A pace that matches the worst season in recorded history. The data is already telling us what comes next. The question is whether anyone is listening closely enough. If you live on or near a coast, or if you have family in the Pacific, in the Philippines, in Japan, in Taiwan, on Guam, or along the coasts of China, we want to hear from you. Do you feel prepared for the rest of this storm season? What is your community doing to get ready? Tell us in the comments. Real experience from real places matters more than any forecast model. And subscribe to the channel if you have not already. This is only the 5th Category 5 storm of 2026, and the peak of the season has barely started. Every new development, every landfall, every record broken, we will cover it here first. If someone you know lives in the Pacific or on a coast, share this video with them. They should know what is coming.